the score y when the coin is spun has the following distribution. So it tells us that the probability when the coin lands on 5, we get p, and the expected value of y would be 3. Okay, so C and D, form a linear equation P and show that P gives you a third, and write down probability distribution Y. Okay, first things first, always do the probability distribution first for any question. This is like a must. So I'm going to start with D first, yeah? Now one thing we know is that this bias coin has one face labeled 2 and another one labeled 5. This means that the only possibilities for this probability distribution would be 2 and 5. Meaning the probability of getting this, probability of y, would be, firstly, we know that probability getting 5 would be p. That means the probability of getting 2 would be 1 minus p. This is because the sum of these two must always equal 1. The sum of all probabilities must be 1. And to get this right, you have to do 1 minus p. Okay, so that's easy. Now, as for the second statement, it says that the expected value of y is 3. So if we calculate the expected value, we need to equate it to 3. So let's do it here. So the expected value y is equal to, firstly, y times py. So 2 times 1 minus p plus 5 times p. And it must equal to 3. Now, all you do is literally solve this. So let's try and sort it out. So expanding the bracket, you should get 2 minus 2p plus 5p equals 3. 5p take away 2p is 3p. Minus 2 across, you get 1, hence p equals a third. This means if we're going to update our probability distribution, what do we have? Let me change color pen. So p here is going to be 1/3. And 1 minus p, so 1 minus 1/3, well, it has to be 2/3 anyway. It has to be 2/3 because the total must give you 1. And that's it, guys. That's all you need to do.